These are the solutions for the practice test. So 210 degrees in radians. And hopefully we have some sense of the unit circle now. So we're going to visualize, here's 180, here's 210, right? So that's the same as 7 pi over 6. And if you don't see that from the unit circle, then you could always do 210 degrees. And we could treat it just as a conversion problem the traditional way, that we know that there are pi radians for every 180 degrees. And when you multiply that out, you get 210 over 180 times pi. 210 over 180 pi radians. And since 30 goes into both of those numbers, I can reduce that to 7 over 6 pi radians. Okay, number 2, the radius of a circle is 6 centimeters, so I'm looking for you to write down the given information. Find the length of an arc swept by, so we're looking for the length of an arc, that means we're looking for S. Swept by a central angle of 210 degrees. The angle is 210 degrees. So if I was to look at the picture for this one, right, if I have an angle of 210 degrees, that's this angle, and if my radius was 6 centimeters, I want to know this arc length. What is the distance around that edge, if 6 is the R? And so we have a formula, S equals theta times R, but theta has to be in radians. Now remember from your quiz, when you're using the S equals theta R and the V equals omega R, the theta and the omega need to be in a radian unit. So 210, well, we already know from the problem 1 that 210 is 7 pi over 6 radians. That's the theta. And we're going to multiply that by 6 centimeters. So 6 is going to cancel when I multiply, 7 pi times 6 over 6. And I end up with an answer of 7 pi centimeters. That's the length of this arc around the circle. Number 3, find the linear velocity. So it's asking for V, linear velocity, of a point, that's that. Of a point on the rim when the diameter is 40, so that's telling me that R is equal to 20 centimeters. And it says that it's rotating at 600 revolutions per minute. That's telling me that omega is 600 rev per minute. Well, very good. We can do V equals omega R, but omega needs to be in radians per second, so we're going to convert this. We know that there are 2 pi radians for every 1 revolution, and it actually doesn't say we need to go to seconds, so we can leave this in centimeters per minute. We don't need to go to seconds. So 600 times 2 pi is 1200 pi radians per minute. So I just converted omega to radians per minute, and now if I multiply omega times R, so if I take 1200, do that here, omega times R, 1200 pi radians per minute, and I multiply that by 20 centimeters, my radius, I'm going to get my velocity in centimeters per minute. Which is 24,000 centimeters per minute. Okay, number 4. We have a go-kart has a tire diameter of 1 foot, so the radius is 0.5 feet, a half of the rate of the diameter. The go-kart has a linear velocity, so V equals 12 feet per second, and it asks you to find the angular velocity in radians per second. Well, V equals omega R, so omega, we could rewrite this, divide both sides by R. Omega equals V over R. So 12 feet per second over 5 feet, and that's going to give me omega, and when I do that, I get 24 feet per second. So the answer to number 4, I'll put it down here, number 4's answer, 24 radians per second. And I'm going to do number 5 on the next page, just to not get this one too crowded here, which I think it might already be too crowded. Okay, so this question says, what quadrant are these angles in? And give 2 coterminal angles for each. So on the degree one, right, we know one is 360, one circle, and the next circle, we could count 450, 540, 630. So going around the second time, I'm counting up by 90s, and then 2 times around is 720. So 700 degrees is definitely in quadrant 4. 700 degrees is in here somewhere. Finish it off. Okay, now 2 coterminal angles. Well, we could say all you have to do for coterminals, remember, coterminal angles, you just have to either add or subtract 360 degrees, or add or subtract 2 pi radians. That's it. So if I add 360 to this, I get 1060. If I subtract 360 from that, I get 340 degrees. I could also say I could subtract another 360, and I could get there by just going negative 20 degrees, that blue angle. Okay, so 29 pi over 6. Well, this is in sixths. And we know that when we go around the unit circle, we're counting in terms of whole pi and 2 pi's. 1 pi, 2 pi, 3 pi, 4 pi. So we want to really look at, where is this? I'm thinking about, okay, well, 6 pi over 6 is 1 pi. And 12 pi over 6 is 2 pi. And 18 pi over 6 is 3 pi. And 24 pi over 6 is 4 pi. I just can divide my 6 into my top number. So 29 divided by 6 is going to give me 4 pi plus an additional 5 pi over 6. That's my remainder, right? So this is equal to 1 pi, and this is equal to 2 pi, and this is equal to 3 pi, and this is equal to 4 pi, and I have 5 pi over 6 left. Now, thing is, we're going in the negative direction, so let's take a look at this. Negative 29 pi over 6. I'm going to go negative 12 pi over 6, negative 24 pi over 6, and I need to go another 5 pi over 6. That's this right there. I'm one short of the negative 6 pi over 6, which would get me over to that negative pi axis. So to find 2 coterminals, I could subtract 2 pi. I could add 2 pi. I could visualize this and say, well, from here to here, that's 7 pi over 6. There's lots of choices I could do. So what I'm trying to say on that, and we'll skip over to the sheet to finish this one up, is if we picture our pi over 6's, and I'm going in the negative direction here, right? And we divide pi into 6's, what this is doing is I'm saying minus 12 pi over 6, minus 24 pi over 6, minus 29 pi over 6. So like I said, is you can add 2 pi or subtract 2 pi from any radian angle to get a coterminal. So if we take this one and we say negative 29 pi over 6, and I add 2 pi, well, that has to be in sixths. So negative 29 pi over 6 plus 12 over 6, that's 2 pi, 12 pi over 6. That gives me negative 17 pi over 6. So that would be coterminal with negative 29 pi over 6. And I could do that again. Negative 17 pi over 6 plus 12 pi over 6. And that's going to give me negative 5 pi over 6. Well, that makes sense, because we know that this angle is negative 5 pi over 6. And I could do it again, and if I did it again, what you're going to find is you're going to get positive 7 pi over 6, but we know that because positive 7 pi over 6 is that angle. So those are all coterminal with negative 29 pi over 6. So I just actually did 3 of them. All right, so that's the first page. That's the end of this video. If you want to see the next set of problems, you can watch the next video.